Hello everybody, I'm Dr. Naveen Sundar. My room number is 001, Computer Science Department, Cabin 3, and my mobile is 98431 I'm going to teach you what is computer architecture. And in this slide you are seeing the subject title and the subject code 14CS2005 Computer Architecture, and there are different books references for this course for your reference. So the outline of this course is why we are going to study the subject and what are the things we are going to study, and then you will clearly understood what is computer architecture from this course. The objective of this course is to learn how computer works and what are the basic principles of the computer, and also we will learn how to analyze their performance, different components performance, and how the computers are designed and how it will be built. And also we will be concentrating in the issues which are affecting the modern processors. So how the catch technology works, and introduction about the pipelines, how the instructions can be executed efficiently. The course will be motivated in designing and building a new version of a computer, and also to improve the system performance in terms of cost, speed, and so on. And also you will be clearly knowing what is required for purchasing the computer. Now we are going to see what is computer architecture. If I go to a civil engineer, if I ask what is architecture, he will tell the building the architecture, that is the structural design. If I go to the electrical engineer, if I ask what is the computer architecture, he will talk about the circuit design. If I go to the computer engineers and if I ask what is computer architecture, they will categorize the computer system into hardware and software. Example for hardware is the physical parts of the computer system, and when we tell the example for the software, we can tell the programs. Again, when we categorize the software, that is the set of instructions, it can be categorized into system software and application software. Example for system software, we can tell all the OS, that is Windows 7. And when we tell the example for the application software, all the editors, example Photoshop. So as a whole, how we can tell user can we interact with the hardware, in which the hardware above which the operating system will be loaded, above which we can tell the application programs, so that the user can easily interact with the application program and indirectly interacting with the hardware with the help of the operating system. Again, for application programs, we can tell all the examples like gaming softwares, editors, and all the programming languages editors like Visual Studio and so on. When we talk about the hardware, that is the physical parts of the system, how we can categorize. Initial part is a central processing unit, CPU. It is called as the heart of the computer, and we can say it helps us to receive and execute the instructions. Come to the next category, we can say main memory. What is the role of the main memory? It holds instructions that are about to be processed, temporarily stored in it and do the for processing, and then finally storing the result back. Coming next, the hardware parts is the secondary storage. Example, hard drive, DVD, etc. And finally, when we talk about the hardware parts, we can tell input-output devices. What's an example for this? The examples for input-output devices we can categorize monitor, mouse, keyboard, etc. and so on. So till now we have seen about the input devices, output devices, central processing unit and main memory as a whole, how we can relate to one another using one human architecture. We can say CPU, which helps us to do the ALU unit, that is the arithmetic and logical operations, and control unit, which helps us to instruct what physical components to do what work at what time, and the input output devices will be connected with the CPU, and finally we are using the main memory as a temporary storage to store the data and do the process and store the result back to the memory. When we talk about the main memory, we can tell example is RAM, that is random access memory. We will see about the RAM in detail in the coming sessions, but we will see about the volatile property of a RAM, that is the main memory. That means it stores the information and it will be lost when there is no flow of electricity. Now considering a kitchen analogy, that is the computer architecture concepts. Till now we have seen about the hardware, software and how the data will be handled, and when we see these concepts in the real time using a kitchen analogy. So hardware is like a kitchen utensils. So it provides the tools that is needed to implement a recipe. So when we consider the software side, we are preparing the recipe that will be considered as a program instructions that will be decoded, and finally we are executing it, forming the result. So that is the cookies we are going to make it, that will be considered as the final result. So as a whole in the software part, how we can categorize the input, output and the processing. So here we can tell the input data, all the data handling what we are going to use is can be for preparing the cookies. We can tell eggs, chocolate, flour and all these things we are considered as a input data, and we are going to process it using the recipe. We are going to form the step how we are going to make, that is the instructions, and after that we are going to get the output data. So output data, that is the thing we are going to prepare, what cookies we are going to prepare. That's the end of class 1. Thank you. See you again in the next class.